Hello everyone. In this lecture, we are going to see why wind-induced vibration happens. We have all these courses available on our Thinkific platform. To learn more about these courses, register with the link given in the description.
Wind-induced vibration. So I have a very nice clip for you. Let me just share with you, and then we'll again discuss. So let us first talk about, best ways to see that wind-induced vibration. Okay. You can see a very tall pool kind of thing. It's not a tower, or see the effect of wind. Oscillation. Very good, Hemant. Now, why this oscillation happens, that we'll try to understand. This is, see the vortex creation. Okay. Now, if you have noticed, in the first video, let us now again understand this, see the second video also. Then you'll be able to understand it even much better way. Let us see that, and then we'll discuss about it. Okay. So the Reynold number is increasing. So at 6 now we are at Reynold number 10. So when we are near to the Reynold number 10, you'll see that vortex creation. Okay, here that two different currents, one is this clockwise and other anti-clockwise. Two vortex creation happens. Now once we move ahead, this is just a vortex creation. Okay, once we move ahead with that, see that the Reynold number is increasing. Now we are at now at 15, 20. Reynold number, now we are at 60. Okay, so this is Reynold number 60. Now what happens? So at Reynold number 16 to 80, what exactly happens? Just a minute. I'll just make it for you. I think it's better to see in this view, so that we can see the exactly what happens at Reynold number greater than 60 to 105. Just look closely at this location, then you will understand what is happening. See this vortex creation, ED currents. See now how violent it has become. See that alternating manner it is behaving. See it? So now there is a vortex created, that ED currents which are separated, and they behave alternately. They try to apply a force which is alternative. So once this pressure is high, it will try to exert a force in this direction. Okay. So now you'll also understand that when there's a wind-induced vibration, the direction of wind-induced vibration is not in the direction of wind. It is in the direction of perpendicular to the wind. That is really interesting. If wind is happening in this direction, the wind-induced vibration will happen perpendicular to it. Making sense? So the wind-induced vibration, the direction of wind-induced vibration is perpendicular to the actual wind velocity. That is really interesting. And see that it's creating alternating force. So because of alternating force, we have oscillations. Making sense? I hope you're able to understand now what exactly that wind-induced vibration is. Is it clear, guys, how it happens and how that equipment behaves in a wind-induced vibration? Let me know if it is clear, or any doubt, let me know. Okay, Amol is saying, can you repeat again? Yes, I'll repeat. Okay, Now, if you see this, this diagram will explain you in a much better manner. Okay. See, if we have very ideal fluid, okay, very ideal fluid which does not have any compressibility, does not have any weight, does not exert any friction, that wind will not create any wind induced vibration. Okay, so ideal fluid will not create anything. Now, once we don't have ideal fluid, because we in real life we don't have that, so for that, those winds are actually having density. Okay, it's not a weightless thing. It will exert friction, and because of that, your wind induced vibration will happen. How that happens? Once your Reynold number keep on increasing, and it happens to Reynold more than Reynold number 60 to 150. Okay, once your Reynold number is very high, that time also that wind induced vibration will not be seen. So wind phenomena. Okay, before going to that, let us see this again if you have not understood this concept. So now see the Reynold number is at 60. Okay, so till that it was okay. There was no wind induced vibration. Okay, once we are going ahead, see now there are fluctuating vortices which are created, and because of these ED currents which are created and now they are separated at our Reynold number 60. So once they are separated, and they keep on changing in magnitude. So see that fluctuation, that blue color which you see, that is the pressure which is exerted. So because of this pressure, there will be force, and because the pressure is also changing in an alternating manner, your force will also change in an alternating manner. Getting it? Yes, raised zone is very high pressure. So here actually what we are trying to say is the two different flows. That red zone is not like here it's blue, that is the other left and right hand side. Okay, because we want to see the different colors of vortices. That is the reason we have indicated in the two different color. Okay. Making sense now, Amol? Is it clear how that wind induced vibration is happening? Okay, great. Now guys, tell me, if there is alternating force acting, what will happen? What will happen to what additional design we have to perform because of this that now you understand that wind design which we did, that was completely different than this induced vibration. Okay, wind induced vibration does not occur at very high speeds. Okay, wind induced vibration, please listen to it very carefully. Many times we get confused that if my velocity is very high, that induced vibration also will be very high. No, the wind induced, now we'll also understand that why that phenomena happens, why that is. Wind induced vibration is very frequent when you are at approximately 40 km per hour. That wind velocity, if it is at 40 km per hour, that time your wind induced vibration is maximum. Okay, because why that is maximum at 40 km per hour? Because that time the Reynold number is approximately at 60 to 150 zone. Okay, and that is where that vortices and ED current gets created. Once the velocity is moving higher than that, there won't be any ED current. And if there is gustiness in the wind, you remember gust, right? So if the wind is gusty, then also vortex shading will not happen. At higher wind velocity, there is also gustiness in the wind. And if there is gustiness, wind vibration will not happen. Okay.